Moving on to 8.2 Bronsted Lowery concepts for the acid and bases. The concept of acid and bases was further elaborated by J. Bronsted and T. Lowery independently by defining them in a different manner. And according to these definitions, a Bronsted acid is a proton donor and a Bronsted base is a proton acceptor. And in this respect, a proton is defined as a nucleus of hydrogen atom and it has nothing to do with the protons in a carbon atom or a sodium atom or any other atom. Hydrochloric acid is a Bronsted acid since it donates a proton to water according to the following equation. HCl plus H2O gives us H3O positive plus Cl negative. Since water accepts a proton, it is a Bronsted base. And after accepting a proton, water is converted to hydroxonium ion, and the hydroxonium ion is in fact a hydrated proton. Some more common Bronsted acids are sulfuric acid, phosphoric acid, and acetic acid. The Bronsted bases have been defined as those species which accept a proton. Thus, in the following equation, water is a Bronsted base since it accepts a proton from sulfuric acid. Also in the equation below, ammonia accepts a proton from water, therefore ammonia is a Bronsted base and water is a Bronsted acid here. NH3 plus H2O gives us NH4 plus OH minus. It is important to note that water behaves as a Bronsted acid in the presence of ammonia and as a Bronsted base in the presence of hydrochloric acid or sulfuric acid, and there are many other examples of this type of behavior. For example, in equations below, acetic acid is Bronsted acid or Bronsted base in the second equation. The interesting information, the wild lupin plant takes nitrogen from the atmosphere and produces ammonia. It was the ammonia to fertilize the soil for itself and surrounding plants.